Alright guys, this is the last video in my Circuit Maker tutorial series. I wanted to update on something on the end of the last video. Two things actually. So the first one was when I saw that I had like 20 something violations here. I was wondering what that was. It was actually a silkscreen violation. So if I scroll down here I can see that this is the violation that I had. Silk to solder mask clearance. That's not a huge deal, and it's not going to break anything. It's basically saying that this little border here, which is just it's drawn on, it's not even part of the circuit, is not meeting the clearance that they expect it to be. But it's not going to by any means break the circuit. I just want to let you know that that's what the violations were. It wasn't any major violation. If I were to, let's say, delete this trace and rerun the design rule check again. Let's see. You see now I have 21 violations. One of them is an unrouted net. That's a big deal. And if I click on it, import polygon, unrouted net. Oh, here we go. It'll show me which net it is. That's an important one, and I can fix that easily just by doing that. Okay, that was the first thing, and then the second thing was I forgot to tell you guys. Once you have your PCB set, the size set, you actually want to define the outline of it, and that will be done automatically. Go back to, so I know that I can't make this any smaller. It looks good to me. I'm going to go to board shape and create primitives from board shape. Everything there looks fine. I never really mess with that. And we're good to go. So what that did, if I go back to view and single layer mode, and now I'm just going to look at the outline, you can see it added this border, this outline around the board. So it's kind of saying, okay, here is the border of my board. This is where I'd be cutting it out essentially. Now you don't always have to do that, but it can mess some stuff up if you don't define your border explicitly. Okay, so that's the whole thing with the PCB. That's all done. And in this video, I'm going to explain to you now if I want to take this PCB, export it in a particular format so that I can have it manufactured at Osh Park, or maybe I want it to be milled if you have another mill at your school or whatever. How can I do that? And you do that by exporting it to what's called a Gerber file. And what a Gerber file is, it's a standard schematic, a standard PCB format that basically it's a series of files that explain what's happening in each of these layers down here. So the top layer, the bottom layer, the outline, way at the end, all these layers you can see here, all the way to the end where we get to the like the paste and the overlay. That's like these little indicator type of things. That's what that is. So it's basically it's a series of files. Each file kind of describes what's happening on each layer, and you do that in Circuit Maker by going Home, Projects. I'm going to go Projects, Generate Outputs. It's going to say, hey, before you generate these outputs, we have to save and commit the file. Just say OK. So it's going to save it. It's going to commit, since I modified this a little bit. And there's a lot to this here. You can actually generate a bill of materials. Say you wanted to order all these parts off of DigiKey. You can check this, and it will set probably like an Excel file or some equivalent that will say, I want 2 capacitors, this particular chip, an inductor, and a diode, and these little header pins. And so you can easily order the parts. You can you can have some 3D prints made. All that is cool, and you can look at that in your own time. The important ones are the Gerber files and the drill files. So we want to make these two for sure, but we also want to configure exactly what it is that these files are exporting. So go to Configure. None of this really matters too much. You keep it in inches, and this format is basically the resolution of it. Different manufacturers will have different resolutions. A lot of times 2.4 is the standard. So let's just say we change it to 2.4. If we go to Layers, here's where we can pick which layers we want. So let's just, starting from the top, let's just do all of these layers. So I'm saying I want the overlay, the paste, the solder, the top layer. The important ones here, you want the top layer, the bottom layer, and the outline. Right here. I think that's the outline. And let's do the same thing. So basically all these files are, I want the top layer, that's this guy, and then all of the extra things on top. So that's like the labels and things like that. And then I do the same thing with the bottom. I want the bottom layer, and then the solder and the paste and all those indicators. And I also want the outline. That's like the border. And if you have any things that you're drilling in, a lot of times that's important. Those are usually the most important ones. A lot of times you can get away with just doing the top layer, the bottom layer, and the outline. So I got the top layer, the bottom layer, and the outline. That's really all you need, but let's just generate all of them because why not? We want to be able to see these labels and stuff too. Drill drawing, nothing important there, nothing important to deal with here. In the advanced, none of these are really important other than we don't need these, and none of these are important other than the fact that they need to be consistent with our drill file. So I'm actually going to kind of configure this as in reference to what Othermill suggests. I'll link this into the video description, but this goes through picture by picture as to what settings you want to select. So it's saying go to your outputs, you want, just like I've said, to click your Gerber and drill, you want to configure them. It suggests to do 2.3 instead of 2.4, so maybe let's do that instead. Back to general 2.3. It only needs the top, bottom, and outline layer, but we'll generate these other ones too, so I can show you how to use this same format for if you're going to get it professionally done with OshPark or something. And then here it basically says, none of these really matter, you just have to make sure that these are unchecked, this is a separate file per layer, and that these match your drill file. So let's actually match our setup with theirs. So if we go to advanced, we want separate per file, we want to uncheck all of these, and they say to do suppress leading zeros, reference absolute origin, and unsorted. Unsorted, reference absolute origin, suppress leading zeros. Okay, perfect. That looks good. Our Gerber file is configured, and we'll do the same thing with the drill file. So we want this to be consistent, so we'll do 2.3. And again, we want to reference absolute origin. Let's see, absolute origin, leading zeros, unsorted. Suppress leading zeros, we don't want anything down here checked. And that looks good. So, suppress leading zeros, reference absolute origin. Okay, that looks good. Everything's configured. We've kind of told it what layers we want it to generate. And now, let's see this. And now we can hit generate. So, going back to here, I'm generating the Gerber file and the drill file. Let's hit generate. And let's give it a name. Buck is fine. I'm going to put it onto my desktop so it's easy to get to. We'll save it. Perfect. And here it is on my desktop. Let's extract it. And I should have made a separate folder. Let's just call this PCB. I'll put all these files into the PCB folder. Now for Othermill in particular, they need you to do a couple specific things. The first thing is they need you to go into the drill file and take this text document. You can't see the types at the end here. I believe you go to View and then Extensions. So you want to be able to see the extension here. That's pretty important if you're on Windows. We're going to copy this file. Oops. Control C to copy. We'll go back, go and paste it into the Gerber file, just like that. And the other thing is we're going to rename this outline extension. So hit rename. The name is fine, but we're going to rename it to GKO. And say, yep, that's fine. I'm not exactly sure what it is about having to change it from a dot outline to a .GKO, but that's what other mill wants. It sometimes doesn't work if it's called a dot outline. All the stuff inside is the same, but it wants it to be that particular extension. So let's try looking at what the other plan software looks like when we load this board onto it. Just for some fun, we'll open Files, go to my desktop, and click that, and it will kind of auto be like, okay, that was your top layer G, bottom layer BL, outline GKO, and the holes, that's coming from your drill file, is that text file. And so now I can actually see it, which is pretty fun. And let's kind of make sure that it looks like what we want it to look like. And it does. There aren't really any holes in our design here. We've got the 2 holes from our inputs, little header pins there and there. Everything else is surface mount. It looks pretty good. If we remember correctly, let's go back to our PCB. We have our chip here. You can see that here. That looks good. We have our different capacitors here and our inductor. Everything on here looks pretty good. And if we wanted to mill this out, it'd be good to go. If we were to get this professionally done, for example, we would go to a website like OshPark, and let's just upload our file here. OshPark actually wants you to upload the file as a zip file, so we can actually just hit the zip. It'll upload it and show us what it looks like. Just give it a second here. And all of this looks good. Our project doesn't contain a bottom silk screen. That's fine, because we actually don't have anything on our bottom silk screen. Let's just put my email there. Continue, and we can actually see what it looks like here. And this looks good. This includes the silk screen, since if you get it professionally done, they're able to do that. We can see our connections here look like what they are, and they kind of break this down into the top and the bottom layers, the hole. So this is what the copper looks like, and all of that looks good to me. Actually, other than this, these should have holes. So I'm wondering if I need to change my drill file. Let's see. If I go back to here, and I zip this whole thing back up. Well, that's for another day, since we're not going to be using that right now. But you'll have to muck around with that a bit, and you know, that's why you look at this and you see, well, there should be holes here. So something happened with our drill documentation, and you'll have to kind of mess around with that. You can see our drill doesn't have any holes here like it does in the other mill design, and that might have to do with its naming convention or something like that, or it might have to do with, for some reason, our holes are in this weird little spot. Little bit of trial and error. I'm sure you can figure it out. But that's that. And now that our whole project, our PCB and our schematic is exported as a Gerber file, we can make our board either professionally with OshPark or quickly with, you know, with your other mill if you happen to have one at your university or whatever. Alright, that's the series. I hope that helped you out a lot. Feel free to send me an email or whatever if you have any questions. Thank you.